Let's get on this. Which of the following is a defining property of parametric models? Parametric models have fixed parameters. They assume the relationship between the input and output. So let's see. A would be model complexity grows with the size of the dataset. That's for the non-parametric property. B would be they have fixed number of parameters and independent of dataset size. That would be true if we look at other options. C is they cannot be trained with small datasets. That is also false. Parametric models are good with small datasets. D would be they always require nonlinear transformations. No, parametric models work with linear transformations mostly. So the answer would be B. That is true. Which one of the following is true? Decision tree split nodes. It does split nodes and parametric in nature. Uh, Not really. Decision trees are non-parametric in nature. Random forests are non-parametric. Linear regression is parametric in nature that can handle data with any size. That is true. Parametric models are always better. Never go for the option that says always. No, random forest is a non-parametric model. Assertion the model built on linear functions are always parametric. Reason is parametric models have fixed set of controls, weights and biases. R is true, but A that is true that linear functions tend to go good with parametric models, but that is not always true because support vector machine model uses linear function, but when using with non-linear kernel it will be non-parametric, so the always function would be negated over there. So that I would say A is false, R is true. Yeah, A is false, option D. Correct. Which scenario illustrates non-parametric behavior? First thing, no fixed parameters, no assumptions. These are the things to look for. A stove with 4 knobs controlling the temperature, it is a parameter that is controlling the temperature, like controlling the function. A spring with a fixed spring constant, it has a fixed parameter, it is parametric. Number of security guards needed for a music concert increasing with crowd size, that is true. Security guards do need to be increased if the crowd size is increased. Two hands holding multiple objects, we have two hands, that is fixed parameters. No, so the answer would be C. Correct. What are the parameters in a linear regression model? Weights and biases. Now, so the options are number of rows and columns in a dataset. No, they are features. Number of rows and columns are different. Coefficients and intercept. Yes, slope and intercept. That would be the parameters. B would be the answer, but let's look at the other options: mean square error and learning rate and number of iterations. No. Yep. If you add more features to a parametric model, what would happen? It doesn't change anything because parameters are same. Adding features is not going to change the function. Like in a linear regression, if I'm adding more number of columns, parameters are always fixed. Y is equals to mx plus c. So the number of parameters increases proportionally. Parametric model, no, parameters doesn't increase in a parametric model. Number of parameters stay fixed, that's true. All the model becomes non-parametric automatically. Not really. That is tricky. Parameters decrease. Adding more fat features is decreasing the parameters. Wow. No, the answer is this question. Which of the following is true and considered a disadvantage for non parametric algorithms? Can handle very large datasets. It is true and it's an advantage, it's not a disadvantage. Model becomes very powerful and makes strong predictions. That is true and it is an advantage. Model tends to overfit. Yes, it is one of the biggest disadvantage of non-parametric models. It tends to overfit the training data. Algorithm does not make assumptions. Non-parametric models do make assumption. Sorry. It does. That is true, but that's not a disadvantage. That's an advantage. Yes, C is true. So the option would be C, and C is true. Parametric machine learning has high bias and tends to underfit the model. Non-parametric machine learning has high variance and tends to overfit. Both are true. So that would be option D. Yes. So a streaming platform wants to predict how long a user will watch a new movie based on their past watch history. They use linear regression with fixed set of features, that is age, genre, preference, past watch time. Yeah, okay. We have fixed set of features, that is fixed parameters. that would be considered as parametric model. Okay, option A is this is a non-parametric model. No, this is a parametric model because the number of parameters are fixed. Yes, it has to be option B. Next, streaming platform uses a linear SVM to classify users as likely to subscribe to premium or not based on fixed features, which is true. Streaming platform uses a linear SVM to classify users as likely to subscribe to premium or not based on some fixed features. Okay, linear SVM is parametric because the hyperplane is defined by fixed weights and biases. Linear SVM is non-parametric because the number of users affect weights. Linear SVM is non-parametric because it stores all user data. Linear SVM cannot classify categorical data. Linear SVM is parametric. It's not specifying anything about the kernel. So I believe A. Yes. It is fixed by weights and biases. Okay, a recommendation engine uses Gaussian process to predict user ratings for unseen movies. Why is this non-parametric? Not sure about Gaussian process. Let's get with non-parametric. It uses fixed weight. That's false. Parametric uses fixed weights. Gaussian process cannot handle continuous ratings. It only works for linear relationships. Its complexity grows as more user ratings are added. No, non-parametric, yes, D option is right. It complexity, wait. Yeah, it has to be D. Yes. A recommendation engine stores the top 1000 similar users for each new user to predict movie preferences. It means for every new user, I'm adding 1000 more similar users in the database. God, that's a lot of data. Parametric because it uses fixed weights. No, it's not talking anything about weights, but instead it is saying the database is increasing, the features are increasing. So it has to be non-parametric because the complexity increases with the data. Yes, it's B. You are tuning a deep neural network. Which combination of hyperparameters would likely to increase variance while minimally affecting bias? Variance is increased. Okay, let's look at the options. Reduce number of layers, increase the weight decay, increase number of layers, reduce dropout, reduce learning rate, increase batch size, use early stopping aggressively. What is the combination that's increasing the variance? That is, if the number of layers are increased, variance is directly proportional to the complexity of the model. So our answer has to be B. Yes. In a production batch pipeline, which of the following monitoring metrics best indicate a bias problem? I would say high training and validation error. Bias is when the training data itself is not able to perform well. Correct. A model deployed in production suddenly shows degraded performance on new streaming data. Upon analysis, training error was low but test error is high. What is the primary culprit? If the model is performing really with training data and not performing well with test data, that would be considered as overfitting. So the primary culprit would be option B, high variance due to overfitting. Yes. During model evaluation, you notice that both training and validation errors are high. Which combination of strategies increase the most appropriate? Increase model complexity and add more features. When training error and validation error both are high, that is underfitting. Yes, I would increase the model complexity and add more features because underfitting happens when there is no sufficient data to train the model. So I would stick with option A. Option B is reduce model complexity and increase regularization. Regularization is to avoid overfitting. So no. Keep model complexity constant and reduce training data. Already the training data is less. Why would I try to decrease it more? That would deteriorate my performance drastically. Applying dropout to prevent overfitting. When it is talking about underfitting, why would I try to prevent overfitting? So the answer is A. Which of the following best describes the relationship between bias and variance? Increasing model complexity increases both bias and variance. Oh, the relationship between bias and variance is always inversely proportional. As bias increases, variance decreases. Let's see. Increasing model complexity increases both bias and variance. No. And another thing is variance and complexity are directly proportional. So increasing model complexity decreases bias and increasing variance. This is true mostly. Let's look at the other options. Increasing model complexity decreases variance. No, because complexity and variance are directly proportional. That negates it. Bias and variance are independent of the model complexity. No. So the answer would be B. That's true. A linear regression model on a highly nonlinear dataset typically exhibits. Okay, we have data distribution that is nonlinear, that has nonlinearities in it, and I'm trying to fit it with a linear regression, a linear model that doesn't deal with nonlinearities. It means I won't be able to perform well in training itself. That would increase the bias and decreases the variance. So answer has to be A, high bias and low variance. That is true. Okay, a deep neural network on a small dataset typically exhibits. The features are very less when I'm talking about small dataset. When the features are very less, I would say it has to be having higher bias. The answer is wrong. Why would it have higher variance when the data is already small? Okay, I'll tell you how underfitting and overfitting works is. With a small analogy. Imagine a big elephant is really hungry and I am giving it one banana to eat. The banana is not sufficient for the elephant. The elephant is still hungry. That is a case of underfitting. And the overfitting comes when I am giving 10,000 bananas to the elephant. The elephant has eaten a lot. This is kind of a metaphorical case of overfitting. So, when underfitting, where is a variance when there is small data? So it has to be high biased. Highly variance is when we have a lot of options and a lot of complexity. This has to be looked because neural networks are complex, but that doesn't mean high variance. Okay, we're not talking about underfitting and overfitting. Variance is how varied it is from the actual, how varied the model predicts from the actual prediction, from the actual value. This has to be checked. Batch trained model performs poorly on streaming data due to sudden feature distribution shift. Okay, model is performing very badly when in real time because of some distribution shift. Main causes high bias, high variance, concept drift, low irreducible error. I believe it has to be data drift and the option is not available here. Maybe concept drift. The concept drift have to be data drift. Concept drift is how the relationship is changing and data drift is how the feature distribution is changing. So it has to be data drift. Increasing depth of a decision tree typically, okay, if I'm increasing a depth, I'm adding more complexity, that should increase the variance. Let's look at the options. Reduces bias, increases variance. Increases bias, reduces variance, reduces both bias and variance, has no effect. No, increases variance, option A. That's correct. Regularization in linear models and ensemble averages is bagging. Example. Okay. If I'm using regularization, that is to overcome overfitting. Rule of thumb is use regularization to avoid overfitting. Okay, now what is it doing? Reduces variance, increases bias. Okay, may increase bias. Option B is reduces bias, may increase variance. Overfitting is high variance, so variance has to be reduced if regularization has applied. That has to be option A, but option C is increasing variance, decreasing bias. Oh, there is a subtle difference between option B and C. Is like in option B, variance might increase. In option C, variance is definitely increasing. Option D only affects irreducible error. Why is it affecting irreducible error? Nothing can affect irreducible error. That remains. So option A. Yes. In batch versus streaming, which is true. Batch model always have lower variance. Okay, do not go for the always word. That too always. Streaming models can suffer from high variance due to evolving data. Streaming models can suffer high variance due to evolving data. That is true. Bias is irrelevant in streaming. Nothing is irrelevant. Batch models cannot overfit. Remove the remove the extremist answers here. A and D are like extreme. So I would go with B. Yes, correct. Which of these is a regression task? Regression is predicting something. Predicting whether an email is spam, it comes under classification, yes or no question. Predicting tomorrow's stock price, that is a regression task. Grouping customers by buying habits, that would consider clustering. Detecting anomalies in transactions, that would be anomaly detect. Which of the following evaluation metrics is least appropriate for unsupervised clustering? Clustering means options are mean squared error is mostly used for regression tasks. So I would go for that. I'm like, that is the only thing I know here for now. C. Yes. A cybersecurity team wants to detect unusual login patterns on their servers, but they only have log data without labels. Without labels, unsupervised classification. But want to detect unsupervised learning, but want to detect unusual login patterns, that is anomaly detection. That would be option B, unsupervised anomaly detection. Yes. A financial company wants both group clients by risk profile and predict loan default probability, which combination of methods is required? Supervised regression only, unsupervised clustering and supervised classification. Semi-supervised learning only, dimensionality reduction. So grouping clients is clustering, and predicting loan default probabilities, finding whether that person is going to get the loan or not, that would be classification. So it is option B. Yes. If two models have the same error, but one has higher variance, then that model must have. The question is somewhat tricky. The question is somewhat doesn't make sense here, because it's saying it has two models, but only talking about one model having higher variance and asking for the same model. That is obviously one model is having higher variance, then it will have lower bias. It is not even asking about the second model here. If it was asking about the second model, then it should say then that other model must have. Grammar mistake. Yeah, lower bias. Which of the following is not true? Survey rate satisfaction from 1 to 5, that would be categorical. Ordinal. That is true. Ordinal is having an order, and categorical. Yes, review rating, that would be like review rating. Rating should be categorical. Height of a person, that is continuous and numeric. Yes, that is true. Number of students in a class, that is discrete. That is also true. Temperature in Celsius is ratio. Not really. In ratio, 0 doesn't have any value. 0 means absence of data. So it means kgs, 0 grams, 0 pounds. Interval, we would say 0 has a value like 0 degrees Celsius. So temperature has value with 0. That would consider temperature into interval. So that is the false one. Yes. Age of student in years. Okay. Ordinal and discrete. It is not it could be ordinal, but ordinal is not just talking about order, it is also talking about the feature being categorical, but age of the students has to be numeric. So option A is discarded. Ratio and discrete. In option C is interval and continuous. Interval, I don't think so, because age, here age, zero age is like the person is not even born, but technically he's still alive. Option D would be ratio and continuous. Okay, the ratio is fixed because the zero age doesn't have any value here. It means absence of data. Here it is talking about continuous or discrete. Age in years, 1 year, 2 year, that has to be discrete, right? Okay, the difference between discrete and continuous is discrete is talking about counting. Like discrete values are countable and continuous values are measurable. Like we measure the height 5 feet. So I would go with ratio and continuous. Oh, correct. Okay, so I would go with ratio and discrete because it's in age and years. Oh, the answer is wrong. The answer is ratio and continuous because, yeah, age can take fractional years. I would say 2.5 years. So, yep. Which of the following best describes qualitative analysis? Counting the number of items in a category? No, that is numeric. That has to be a quantitative analysis question. Understanding qualities, attributes, or characteristics? That is true. That is what qualitative analysis is. Measuring weight, height, it is numeric. Calculating averages and standard deviations, that is false. So answer has to be B. Yes. Which statement differentiates quantitative versus numerical data clearly? Quantitative is measurable. Numeric is always integers. Not really. Quantitative is countable. I mean, it is talking about the quantity. Why does numerical always have to be integer? It could be decimal. Numerical is a subset of quantitative data that is numeric. Does numeric mean countable? But quantitative may include ordinal scales. That is true. Quantitative includes ordinal scales, like the satisfaction rate, like we review the rating from 1 to 5. Okay. Numerical is a subset of quantitative data that is numeric and measurable. Quantitative is only continuous, numerical is only discrete. No way. Quantitative and numerical are identical. It has to be either B or D. Numerical is a subset of quantitative data. What do you mean subset? Quantitative data? No, both are identical. When we are talking about quantitative analysis, the quantitative analysis is like the action we are doing for the data. Numerical is the type of the data for which we are doing an analysis. That is called as quantitative analysis. But a subset, I don't consider that. D, quantitative and numerical are identical. I would go with D. No, I wouldn't consider this answer. We'll check again. Identify the nominal or ordinal types. Blood type A, B, A, B, O. That is not ordinal, that's nominal because it's not ordered. Educational level, high school, bachelor's, master's, and PhD, that is ordinal. Satisfaction rating is ordinal 1 to 5. So answer has to be nominal, ordinal, ordinal. Yes. Identify the scale, ratio or interval, temperature in Celsius. As I mentioned, interval has value for 0, ratio. In ratio, 0 means absence of the value. So in for temperature, 0 has a value, so it is interval. Weight in kgs, age in years, calendar in years. So all of the three have to be interval. First one has to be ratio. All of the others has to be ratio. I am not sure why is it interval. In interval, differences are meaningful, no true 0, because age in years is 0, calendar years are also supposed to be 0. We'll search for this. When using mean imputation for a numeric feature like age, the variance of the feature will be preserved. the variance of the feature will be reduced. The correlation with other features will stay the same. It improves model interpretability in all cases. In mean imputation, we are replacing all the missing values with the mean value. It means we have more number of means, more number of values at mean, that is decreasing the variance. Variance is how spread out the values are. Now most of the values are concentrating towards the mean, that is variance is being reduced. I would go with option B, and that is correct. For categorical variables with missing values, a common practical approach is, for categorical variables with missing values, okay, replacing with the most frequent category, replacing with the mean, replacing with zero, always use one hot encoding for imputation. No, when it is talking about category, we'll replace it with the most frequent category, that is using mode imputation. Option A. Yes. Adding a new category missing for a categorical variable is useful when the missingness itself carries information. That is true. The dataset is very small and cannot afford case deletion. That is also true. Models like tree based methods can treat missing as a branch. That is true. Like decision tree or random forest, they could think missing as a branch and start making decisions based on that. Answer has to be D, all the above. Correct? Yes, correct. Then, which of the following statements are true? All qualitative data is categorical, all quantitative data is numerical. Both looks true. Interval data has true 0. No, interval data has arbitrary 0. Ordinal data always allows meaningful multiplication. No, ordinal data is for categorical. Why would it allow meaningful multiplication? It doesn't make sense. So it has to be A and B. Correct. Mode imputation is most commonly used for categorical variables. So answer A is continuous variables, ordinal variables, categorical, and interval. And it has to be answer C. Categorical. Which node is considered pure? Okay, pure node, it is a concept of decision trees where we try to make the leaf node that is in a node having all the similar classes. That would be 5 and 5, yes and no. That would be no. 10 yes and 0 no. That looks same because we have all the similar classes in one node. That is considered pure. So the answer has to be B. Okay, that's true. Using histograms to check numeric features with missing values help you. See whether the distribution is normal or skewed. Identify if imputations distort the distribution. Compare distribution before and after handling missingness. D, all the above. When I am imputing missing values, I would definitely check the feature distribution should not be distorted. So using histograms to check the feature distribution before and after imputation would help us analyze all of the components that they are mentioned. So that would be answer D, all the above. Yes. If categorical data is missing in a feature like region, so I guess if it is talking about a regional data, it has to be important. So imputing with unknown might help the model learning if missingness is systematic. It is not random, right? That is true. Reduce predictive power if the missingness is actually random. I think both A and B, because no, it can't be both A and B. It has to be A. It is like I want the model to also understand the missing data, that the data could be missing even in test data. Both A and B. Oh, yeah, correct. Reduce the predictive power if the missingness is actually random. That is the same thing. If missingness, assuming missingness is random, but this needs to be checked. Predictive power has to be reduced if to consider, but needs to be checked. Which missing data mechanism assumes that the probability of missingness is completely unrelated to both unobserved and observed data? That would be missing completely at random. Option B. That is true. Which imputer predicts missing values using the similarity of other observations? Iterative imputer, random value imputer, KNN, end of distributor. I know missing values based on other observations is talking about multivariate imputation. It could be iterative or KNN. I'll go with iterative, but not totally sure. It is KNN. Need to look for the definition again. Which imputation method is most suitable for numeric data and symmetric distribution? Mean numeric data with symmetric distribution, median numeric data with normal distribution, mode most frequent values, missing categorical features. Most suitable for numeric data. When we are talking about numeric data, mode and categorical features are not coming because they are not dealing with numeric data. So it has to be either A and B. But when we are talking about symmetric distribution, it is similar to normal distribution. Both are the same. When the data distribution is normal, mean and median are same. So it has to be A and B. The option is wrong. It has to be A and B. Most frequent value imputation can cause, that is mode. Mode is causing reduced variance in the data. That is true. Adding more similar variables is reducing the variation in the data. Increased outliers, no. Better handling of rare categories, generalization of synthetic values, I'd go with A. That is true. If missing values occur only in numeric variables, which visualization is most useful? To inspect distribution before imputation. Bar chart, histogram, scatter plot, box plot. Histogram. Correct. Which imputation method introduces a new indicator variable to signal missingness? Signaling the missingness. End of distribution imputer is adding outliers into the imputation. Missing category imputer is adding missing value. Mean or median is imputer with a flag adding mean or median values. Iterative imputer, it is a multivariate imputer. I believe it has to be B. It has to be C. Which imputation method introduces a new indicator to signal missingness? Needs to check. Which of the following is incorrect about imbalanced data in machine learning? Imbalanced data. When we have two classes of data, one is balanced. Suppose we have 1000 samples, 100 samples are of class A and 900 samples are of class B. That would make the data set as imbalanced. Now let's look at the options. When data is too large to process, data is large, but that doesn't help anything with the question. When one or more classes have significantly fewer samples than others, this is true. It causes the model to ignore minority classes and focus on the majority. It improves training accuracy but worsens the generalization. D is also true. C is also true. Oh, the question is about incorrect. So A is incorrect. Yes. Multivariate imputation is generally preferred when features are independent, correlation exists between features, missingness is MCAR, dataset has very small size. MCAR is missing completely at random. Multivariate imputation is generally preferred. Oh, it's talking when we are using multivariate, we are obviously expecting that there is a relationship between features. There is a relationship between features. So the answer has to be correlation existing between features. That would be B. Correct. Yay! End of the quiz.